Alright, so this is now review 17. It's still Thursday, and we should have finished up review 16 notes already. So, review 17, area bounded. Let's just start off with some basic things about area. If you are, and I'm going to back up one page. If you're looking at the integral from a to b of a function f of x dx, then that is always the net signed area bounded between the x-axis and the curve. So if I draw a function, doesn't have to be a perfect thing, let's see, and I draw some type of curve here, from A to B, then the integral is the net signed area. So this little negative piece, that would probably cancel with maybe about that much. So the answer to the integral would be positive because the piece that's left over is this. And it would be positive whatever area that is. Okay, so that is what just a plain old integral does. It finds you the net signed area. Now, area bounded is a little bit different because given two functions is usually what we do. Given two functions, say I give you, let's say this guy, call that f of x, and then this guy, call that g of x. The area bounded would be what's stuck in between them. And remember, we have two ways to find the area that's bounded. We want to look at the integral from a to b. Actually, I'm not going to even use a and b. We'll use x1 and x2, and we would do a top function minus the bottom function. And when we do that, that's a dx. And we use that when we know the top function and bottom function pretty much don't change. We want to use that if it's going to be less work. And the other way we find area is right minus left. So in a dx problem, all your equations should be in the form of y equals, whereas a dx problem, your equation should be in the form of x equals. So the two functions, y1 and y2, in this case x1 and x2. Okay? You should make sure that when you solve for x, what it does, everything in your integrand is in terms of y's. There's only y's in here. Remember, these have to be y values. Total area. So total area goes along with total distance is the other time that we've done total area. And total area is a little bit different. It's not just the area bounded. They tend not to mix the two. They'll ask for the total area bounded by the curve, meaning there isn't a second curve, and that was where, if I asked you for the total area of f of x, let's say, so bounded by f of x and the curve, then, or f of x and the x-axis, your steps would be find f of x zeros, or they're also called x-intercepts. 2, we do a sign chart for f of x. And number 3, we add positive integrals. And then we subtract away negative integrals. That might be the easiest way to show it. And then remember, if we want to find total area with a calculator, we can do the integral from a to b of the absolute value of the function. That'll make everything positive. Okay, just a little reminder. Let's see. So we also talked about how we know we are going to need to draw the function. This is very complicated. This is definitely a drawing function problem. So here we go. Cosine of x between negative pi over 2 and positive pi over 2. And then we know that cosine of x starts here. Okay, and here. Alright. So, from negative pi over 2 to pi over 2 is separated into two regions by the line x equal to k. If the area of the region from negative pi over 2 to k is 3 times the area, so now just we know that x, or k, has to be over here. And it has to be 3 times the area. So, then k equals. Alright, so there is my not so awesome picture. So, let's see. So it says that the area from here to here is 3 times the area from here to here. I'm just going to turn that into an equation. So the area from negative pi over 2 to k of cosine of x dx is 3 times the area from k to pi over 2 of cosine of x dx. So at least it's an easy function. So first thing is I'm going to find my antiderivative for both of these would be sine of x. So just be careful with this 3. So next step, f of b minus f of a. So in this case I'd have sine of k minus sine of negative pi over 2 is equal to 3 times the sine of positive pi over 2 minus the sine of k. So negative pi over 2 would be down here. So that's the sine of k minus negative 1, which gives me plus 1, is equal to, and this time it would be positive 1. So I'm going to do 3 times positive 1, which is 3, minus 3 sine of k. And I'll bring all my sine of k's over here. So 4 sine of k is equal to 2 sine, oh, this works out nicely. Sine of k is equal to 1/2. K is equal to 1/2 root 3 over 2, so pi over 6. C. Oh, that worked out nice. I didn't think it was going to. Alright, this guy. So it says, what is the area of the region completely bounded by this curve and this line? You actually can do this problem without drawing the curve at all. So I'm going to just show that you can do it. So in this case, if I'm not going to draw the curves, first step is to find the intersections. And actually, let's even write that into the notes because I don't think I did. So area bounded, remember for these, if no graph is if they just give you the two functions that are bounded. Bounded, that's my quick way of writing bounded. Then the first thing is to find your intersections between the two curves. Remember, they can't do anything about quadrants. They shouldn't be saying it's bounded by the x-axis, the y-axis. Alright. Second piece, you're going to do that kind of fake sign chart to figure out who's the greater function. You're identifying top or right. And then third step is this piece right here. Alright, going back to my problem. So my intersections would be negative x squared plus x plus 6 is equal to 4. I don't like my x squareds to be negative, so I'm actually going to move everything to the other side of the equation. Or I could multiply by negative 1. That'd be negative 2. So I get 0 is equal to x minus 2, x plus 1, x is equal to 2 and negative 1. And then step 2 is that fake sign chart. So negative 1, 2, the number I pick is 0. So then we'll call that y1, we'll call this y2. Oopsie. So y1 of 0 would be 6, y2 of 0 would be 4. So this one is my top function. That one is my bottom function. I know it's the top bottom because these are y equal to. So integral from negative 1 to 2 of my top function, which is negative x squared plus x plus 6, minus my bottom function, which is 4. See? And yes, I would simplify this before trying to find the integral. We do that so that the amount of mistakes you guys make is hopefully less. And then 6 minus 4 is positive 2. So notice this isn't the same as the equation I solved over here. That does happen a lot. Alright, antiderivative. Negative x cubed over 3 plus x squared over 2 plus 2x. F of 2 is negative 8 thirds plus 2 plus 4. F of negative 1 is positive 1/3, positive 1/2 plus 2. So over 3, that becomes 6, 12, 10 thirds, and then I can tell that I definitely made a mistake somewhere. Oh, no, I didn't. No, I didn't. 17, not thirds, it's tenths. 6s. So my area bounded between would be 26 minus 17, 6, which is 3, 6, which is a half, which is so not an answer. I'm going to pause and try to figure out where I made my mistake. You guys might have found it already. Duh, found it. I said it, I feel like, but then I didn't do it. So that is supposed to be negative 1. So there's my mistake. Let me go back through. I will make my mistakes in red. So, negative 1 squared would be positive 1/2 minus 2. Oops. And I believe that gives me negative 7 over 6. And therefore, we end up with 10 thirds plus 7 6, 27 over 6, which gives us 9 over 2. There we go. Stupid little mistake. Alright, that's the last one. There you go. So just make sure you corrected that.